So we're going to first train the tree with CP equal to 0, and we will leave the minimum split as the default value. And cross-validation is part of R part, so you can specify the cross-validation in your R part itself. So when you're using cross-validation, you have to set C for reproducibility. Okay. And then we're going to, let's call this bank.tree.cv for cross-validation. Okay. And then we say R part. Okay. Personal loan. Okay. And data equal to train dot d. Okay. Method equal to class. And now we say, so you don't have to use control and then use control. You set up a control, then use the control in here. You can directly specify the control values in the R part also. So let's say CP equal to 0. Okay, so maybe we'll do min split as well. So min split equal to 1. So it's going to grow the full tree. Okay. And then, if you say xval equal to 10, xval is your number of folds. Xval is how you specify number of folds. If you don't specify xval, then R part will automatically use 5 as your cross validation. So if you don't want cross validation, then you have to say method equal to none in control. Then only it will not use cross validation. Okay. So xval is your number of folds. So this is going to create the folds for you. Okay. And let's do length back tree.cv frame var. Okay. And then so here back.tree.cv frame var equals to, so that's going to give us how many total nodes are there and how many leaf nodes. And we can print this as well. So if you do PRP bank.tree.cv, that will give you a print of the full tree grown by cross validation. Okay. Now this is going to do print CP. Okay, so that's going to give us the table of relative error. Okay, relative error is 1 minus R squared, so that is only for numerical target. X error is what we want. X error is for classification, and we want to find the smallest X error and then read the CP value from that. Okay. So, okay, let's see how to do that. So two-step process, right? First, we have to find the smallest X error. Okay, the row that contains the smallest X error. Okay. Then once you have the row, then for that row, what is the value of CP? Okay, so that's what we are after, right? So we can say min X error. I'm going to do step by step. We can actually combine all of this into one line of code. So, but let's take it one at a time. So let's find the minimum value of bank.tree.cv. Okay, and then we want CP table. Okay, CP table. We want to look at all the rows in the column XL. This is going to go to the CP table, look at the XL column, and then find the minimum value. But we are not after the minimum value of X error, but we want the corresponding CP value. So we need the row. We need min X error row is what we want. So then we can find that using which. Actually, we can use which min. With that also give you the same thing. But here we are doing it one step at a time for us to understand what's going on. So bank.tree.cv, okay, CP table, X error. Now we want to go into that column and check which row, okay, the X error of which row equals the min X error. Okay. Once we have the row, then we can find the best CP, okay, as bank.tree.cv CP table, okay, and we go to that min X error row. If you look at the min X error row, and we need to get the value of CP. Okay. So we find the min X error, and then we find the min X error row. Okay. Now these two can be combined if you simply do which dot min, then you will have the minimum error row. So once you have the row, then you look at the CP table for that row, the column CP. So that's going to give you the best CP value. Okay. And then once we have that, best CP tree will be to prune, okay, bank.tree.cv. So take that tree and then set CP equal to the best CP that we found. So this will now use the best CP to prove the cross-validation, fully grown cross-validation tree back down to the best value. did this. Take that back here. And then we can then do the, no, we can print PRP best CP3. Okay. And of course, we can find the length of the tree and how many leaf nodes are there, and all that we can do. Okay. And normally, when you look for the smallest X error, the X error itself is an estimate only. So, along with the X error, R also prints out the standard deviation of X error, how much variability there is in X error. So, we can go a little more, we can do even further pruning by not just looking at the least X error, okay, but we add the corresponding standard deviation, so you just give it a little more leeway. So, I'm all right if the X error is a little bit higher than the smallest value, but no more than one standard deviation. So you can take that X error, add a standard deviation, and look for the CP for that, and that will prove even further. And I'm not going to go over that, but I have given the code in the PDF file. So take a look at that. So further pruning. So use CP at the lowest level where X error is not just the minimum X error, but minimum X error plus the standard deviation. So what you have to do is to look for all the errors that are greater than this, and then select the smallest CP for that. Okay. All right.